Hello, another whiteboard tutorial. This time we're going to be looking at multi-digit multiplying. Now there are three ways that students are taught these days to multiply more than one digit by other digits. There's actually four, but we're going to get to that fourth one later. The three that we're going to focus on right now are the box method, partial products, and what we might call the standard way or the standard algorithm. An algorithm is any series of steps that are basically shortcuts, and they work. But they organize the information in a very short, compact way. One thing that I'm going to try and point out is that each one of these three ways is basically trying to take a larger number, like 675, and split it into its three parts: 600, 70, and 5. It helps to know a little bit about place value, and this is also a good time to review place value. Let's say we multiply 675 times 3. I'm going to show you three different ways to take apart 675 and multiply each part, the 600, the 70, and the 5, by 3, and then put them back together. 600 times 3, 70 times 3, and 5 times 3. Let's look at the box method as one way of doing that. When you multiply 675 times 3 using the box method, you first take a look at how many place values you have, and you set up I usually set up the larger number on top. Whoops. Boy, it's a late night. I hope you're catching my mistakes too. 675, we might split up across the top into its place values. And 3, hey, that's nice, it only has one place value. You don't often see the box method used for single-digit multiplication, but it works great for that. This would be 600 times 3. We're now going to do each part. And 6 times 3 is 18. And it's nice to know that this is just 2 powers of 10 bigger, 2 zeros bigger. So we end up with 1,800. 3 times 70, well, 3 times 7 is a smaller number we could start with. That would be 21. And since 70 is 10 times bigger than 7, we know that our answer is going to need to be 10 times bigger than 7. And finally, we just have 3 times 5, which is 15. In the box method, you organize the multiplication, the partial products, each of the three place values. You organize it in a box of its own, and then you add them together to figure out what 675 times 3 would be all together. Carry when you need to. And this is our final answer. The box method actually has a lot to do with the partial products method that I'm going to teach you right now. When we look at 675 times 3 written vertically, we can still see that we have these three different place values, and we can still treat them separately if we want. 5 times 3 is 15. Now this 7 is not really a 7. Remember, it's a 70. 70 times 3 is the next step, the next part of this number. 70 times 3 is 210. It's 21. But since it's 70 times 3, there's an extra 0 there to make it 10 times bigger. And the 6 is not really a 6, remember. It's 600. It's in the hundreds place. And when 600 is multiplied by 3, we get 18 with 2 zeros, or 1,800. We can add these up, and I think we are going to get the same exact answer. Now notice, we dealt with the partial products over here in 3 boxes. We dealt with the partial products over here in 3 different rows. But they're the same partial products that we got over here. I don't know if you can tell, I really wanted to color code this. I messed up. But we can get back on it for the standard algorithm. Now, as I said before, the standard algorithm usually organizes everything in a smaller space. Sometimes it will take a little less time, but it usually has shortcuts that get away from the real understanding of why this works. And so while it works great and while it's powerful and fast, and it really is good for people to build to this algorithm, it's important to keep your common sense so you can be a good estimator and so you can do some mental math. Sometimes people who only know the standard algorithm, well, sometimes they can have a harder time with mental math or estimation. But let's look at it. 5 times 3, 15. Now in the standard algorithm, we realize that we're going to write the 1 in the ones column, but we have a 10 in the number 15, so we'll put it up there. We're still going to multiply 70 times 3, and we're still going to get 210. But we're going to take the extra 10 that was left over and add that in. It's very important that you remember to multiply the 70 times 3 first, just like we did in every other time, before you add in that extra 10. But when we do that, we get 21 plus another 10, which is 22. We get 220. So the 20 can go here, the 2 that's standing for the 20, but we're going to have to carry that other 2. So we really got 22, and we're writing 2 here when we write the single digits. 6 times 3 is 18. With that extra 2, we're going to have not 18, but 20. And so when we write that down, you'll see we get the same answer each time. I may have made that a little bit more complicated than it needed to be, but I did want to explain that you have to first multiply 5 times 3 to get 15, carry the 1, then multiply 7 times 3. Don't add the 1 until you're all done with that. And then you get 22. And then multiply 6 times 3 and add the 2 that you carried over. Then you've got 20. I hope you see that we are still trying to get these 3 partial products. We just add them together at different times, and we organize the work in ways that's either easier to see or a little bit more difficult to see over here. I'd also like to show one more way, which is called lattice multiplication. Now, initially I was not a huge fan of lattice multiplication. I thought it was a complicated way of showing something, but it really does make the math a little bit easier. So let's look at this. 600, go, what? My goodness, 675, and we're going to multiply it by 3. Just like before, we're going to make boxes, but check this out. We're only going to make a box for each place value. And then we're going to do something that I thought initially was a little crazy. Oops, I think I put this in the wrong place. Those of you who know lattice multiplication might be laughing at me right now, and that's totally fine. In lattice multiplication, we are only going to multiply a single digit number by a single digit number each time. In this case, we have 5 times 3. We are going to write our answer in a way that starts to organize the place values for us. Here's the ones column, here's the tens column. When we multiply 70 times 3, we're just going to deal with 7 and 3, and we're going to get 21. But now, 70 times 3, remember, should have been in the hundreds column for 210. And now it still is. These are our columns. Our ones, our tens going diagonal, and our I think I said that. Yeah, our hundreds going diagonal, and our thousands. We're now going to multiply 6 times 3 and get 18. Now the cool thing is, this way of setting things up allows us to add the numbers in their place values. So we get 5, and then let's add up the tens diagonally, 2. Let's add up the hundreds. We're going to get 0 and carry the 1, and then we're going to get 2 over here. So we just got 2,025, which I believe was our answer before, and it's in a pretty tight spot. I know I drew it bigger, but the answer of 225 is done in a space that takes up about the same amount of room as the standard algorithm. It does a nice job of keeping track of the decimal places, and I'm starting to come around on seeing it as a pretty nice way of keeping track of the work without making it overly complicated. Some people are going to see all this and think it's overly complicated, but I've seen great students and struggling students alike keep track of this and get the same answer as the other 3 methods. So, thank you for watching. And just for fun, why don't you do a practice problem? 642 times 6. You can organize it any way you like. You can pause it, and when you're done, I'm going to tell you the answer. All right, 642. I think I'm going to go with the partial products method times 6. So I've got 12. 40 times 6 is 240. And 600 times 6 is 3,600. Add those. Oh, you can't see. Add those all together, and we've got 2, 5, 8, 3, 3,852. Now, should I have estimated first? Sure. 600 times 6 should be somewhere around 36 with 2 zeros, but it should be a little bit more because we're multiplying by a little bit more than 600 times 6. So this fits right with our estimate. A little bit more than 3,600. Great. With whatever method you did, I hope you got the same answer.